Alright, testing 1, 2, 3. Okay, this is going to be a video about lesson B13. These are the notes that we had for B13. The lesson is about radicals and rational expressions on section 11.2. And basically radicals has this format where you have a number raised to a power, and this would be the root. And basically you can translate from rational form to exponential form. So the exponent goes on top and the root goes on the bottom. So here's some examples. Express the radicals using exponents. Here I have the square root of x to the first. Okay, how do I change that into exponent form? Basically, I write the x, which is the base. The exponent is 1, and the root is square root, so this would be a 2, because there's an invisible 2 right there. Here's the next problem. I have square root of x to the third, and x to the third is, you can rewrite it as 3 over 2. Okay. Also remember, 3 over 2 is the same thing as 2 goes into 3 one time. You copy the 2. 2 times 1 is 2. To get to 3 you need 1. So basically you have x to the first times x to 1/2. And that's basically why when we did this using radicals, we said, can we take out anything from the radical? The answer is no. But if I rewrite, I was able to take out 1x. This becomes x to the first, which is represented by this one, and a square root of x, which is represented by this one. Okay? Alright, then we'll go to example letter C, which is the cube root of y to the 7th. So to rewrite it, you would write y, the exponent is 7, and the root is the cube root, so the 3 goes underneath. Alright, next problem we have D, letter D, which is 2 square root of p. So basically 2, the exponent is 1, so it just stays like that, and the radical is only covering p, so p to the first over 2. Alright, compare this problem with the next problem. Let's move down a little. Okay, this next problem, letter E, I have the square root of 2p, and now that means the radical covers both of them. So what I do is I put parentheses around the 2p and I raise it to 1/2. You can leave your answer like this, or you can go ahead and distribute the 1/2, so it'd be 2 to the 1/2, p to the 1/2. So that's the difference between this and this problem right here. Okay? Alright, the next one we're going to go is the fourth root of 3x minus 5 raised to the third equals, basically what's inside the radical is the 3x minus 5, the power is 3, and the root is 4. So basically the whole idea here today is about changing radical form into exponent form. Okay? Okay, let's go ahead and continue with example number 2. Example number 2, we're going to do the opposite. We're going to start out with an exponential number, and we're going to change into radical form. Okay, so here we have the problem which says express each expression using radical notation. So basically, let me move up here. Alright, here we have letter A, x to the 1/5. This is an exponential, right? It has an exponent, and we're going to change to radical form. So basically, the 5 is the root, and 1 is the exponent. Y and 2/3. 3 means is cube root, and the 2 will go inside the radical, so it'll be y to the second. Letter C, you have 2x plus 1 raised to the 7/8. 8 is the root, 7 is the power. Okay, and so forth. 2m to the 1/3, 3 would be the root. You write the 2m inside, raised to power 1. Okay, notice here that you have parentheses, and that means everything inside the parentheses is going to go inside the radical. Contrast that with the next problem, which says 2m raised to the 1/3, and the 1/3 only applies to the m because 2 has an exponent, is an exponent 1. So I mean 2 to the first is outside the radical. We open the radical, which happens to be cube root, and we put the m to the first inside. And we usually don't have to write the 1 over there, but we know it's there. Alright, the next problem, we have -9 to the 1/2. Notice there's no parentheses, so it means that the 1/2 only applies to the number 9. It does not apply to the negative. So that means the negative is outside the radical. We write the radical, which is root 2, and we don't have to write the 2 because 2 is invisible. And it would be 9 to the first. Now, the thing is, can we simplify this radical? Yes, we can, because square root of 9 we know is 3. So and we have a negative in front, so it becomes -3. Alright, let's go on to the example number 3. Alright, example number 3 says, express each expression using radical notation. Simplify if possible. So I'm starting out with this problem here, 64 to the 1/3. First thing I do is change to radical form. So because the 3 is on the denominator, I know this is going to be cube root. I write the 64. And then basically we're back to the same previous problems that we were doing on the previous assignments, where you start out by doing the prime factorization of 64. So we break down 64 as 2 and 32. 2 is prime, so you put a circle around it. 32 is not, so you break it down. 2 is prime, 16 is not, break it down. 4 and 4. And 4 breaks down as 2 and 2, 2 and 2. So once we've done the prime factorization, we notice that we have 1, 2, 3, 4, 5, 6. So 2 to the 6. And 2 to the 6 can come out of the radical because you can divide the exponent 6 by the root 3. So 6 divided by 3 is 2. So 2 to the second is 4. Alright? So basically these are the same types of problems we've done before. The only thing is that you're starting out with a exponential. So your strategy should be change this to radical notation. So basically I would write the square root of 16x to the 8th. Do your prime factorization, which in this case I got 2 to the 4th, and see who can come out of the radical. In this case both of them can come out of the radical, so this would be 2 to the second, x to the 4th, and 2 to the second is 4, x to the 4th. It stays like that then. Okay, next one, this is 4/3, so this would be cube root 8 to the 4th. Now what we're going to do is we're just going to leave that 4 for that exponent 4 for out there for a second. We're going to do the prime factorization of 8, which happens to be 2 to the 3rd. Notice how I write. I write 2 to the 3rd in parentheses raised to the 4th. So basically here I had 8 to the 4th. I did the prime factorization of 8, so I'm going to replace 8 with 2 to the 3rd. Make sure to put the parentheses. Now what do I do with these two exponents right here? Well, the rules of exponent says if I have an exponent raised to another exponent, I would multiply these two. So 3 times 4 is 12. And can the 2 come out? Yes, it definitely can. I'm sorry, because you can divide 12 by 3. So 12 divided by 3 is 4. So 2 to the 4th is 16. Alright, letter D, same approach. You're going to have cube root. The denominator goes right here as the root, and the 5 goes inside with the base 4 here. We do the prime factorization of 4, which is 2 to the second. 2 times 5 is 10. Okay, 10 cannot be divided by 3, so I'm going to rewrite 2 to the 10th as 2 to the 9th times 2 to the 1st. 2 to the 9th can come out because 9 can be divided by 3. The 2 to the 1st cannot come out, so there's no arrow there. So this guy comes out as 2 to the 3rd because 9 divided by 3 is 3. And these two stayed in the house. 2 to the 3rd is 8. and that's my simplest form. Okay, here we go for letter E. Our example, 3 to the 2/3. We'll put the 3 as the root, 2 as the exponent, 3 to the second. The 3 cannot come out, so there's nothing I can do here other than just writing it back as 9. So basically it stays like that. This one, x plus 3 raised to the 7/5. 5 is the root, so I put it there. 7 is the exponent, so I put it here. Can I rewrite? Because right now I cannot remove anything, but I notice that I can rewrite as x plus 3 to the 5th, x plus 3 to the 2nd. Writing this way, I can remove one of the x plus 3's, and this one is going to stay in the house. So this guy comes out as x plus 3 to the 1st, and this guy here stayed in the house. Okay? Alright, continuing on. Suppose I have these exponents, but now they're negatives. If you remember, to get rid of a negative exponent, all you have to do is flip the number. So this is 27 over 1. If I get rid of the negative, it becomes 1 over 27/4. Once you get a positive exponent, change the number into a radical form. So this would be cube root 27 to the 4th. Do the prime factorization. Prime factorization of 27 is 3 times 3 times 3. In other words, 3 to the 3rd. Write the parentheses. Make sure that what we do with these exponents, we multiply, so it would be 3 to the 12th. Can the 3 come out? Yes, it can. It comes out as 3 to the 4th. And the final answer is 1 over 81. Alright, next problem. 625 raised to the -1/2. First thing we need to do is get rid of the negative exponent. So we do that by flipping. Once we get rid of that, let's change to radical notation. The 2 goes as the root, and the 1 is the exponent. Do the prime factorization, which happens to be 5 to the 4th. 5 to the 4th can come out. 5 to the 4th comes out as 5 to the 2nd, and 5 to the 2nd equals 25. Remember, you have that 1 on top, okay? Because everything here is on the denominator. Alright, let's go on to example number 4. Okay, we're still dealing with exponents that are fractions. Suppose that I am multiplying these two numbers or two terms, and they have exponents in fraction form. The rule of exponent tells us that we can add the exponents if the bases are the same. The bases are the same, so that means I can add these two. And because they both have the same denominator, I can go ahead and add them. So 9 plus 8 is 17/5. I'd like you to compare. You don't have to do this. I'm just showing this to illustrate what's happening behind the pictures. If we change this to radical form, this would be b to the 9th of the 5th root, the 5th root of b to the 9th. And this guy here would translate into the 5th root of b to the 8th. And if you remember the previous lesson, when we can multiply these two because they have the same root, and 9 plus 8 would be 17. And basically that's the same answer we got. Okay? So what's happening in radical form is also happening in exponential form. So it's pretty cool that how they relate to each other. Okay? Here I was just illustrating that you can also take out, you can rewrite this as b to the 15th times b to the 2nd, and b to the 15th can come out. So the answer would be b to the 3rd, the 5th root of b to the 2nd. Okay, so I just scribble things here during class, but basically the idea is that when you multiply in exponential form, you can add if they're fractions as long as you have the same denominator. Okay, so go ahead and disregard this. This was just some little annotations that I did in class. The most important thing here is we're multiplying these two, they have the same base, and we can add the exponent. Okay, same thing here. I have the same base. What can I do with these? I can combine them. In this case, it's 4 minus 1 equals 3, and 3 over 3 is the same thing as 1. Okay, now there are times when they have the same base and you can add this, but you cannot add it at first because they don't have the same denominator. So it's very important that you remember, to be able to add fractions, you have to have the same denominator. So the common denominator here would be a 6. So in order to make this guy here, that is a 2 right now, into a 6, I would have to multiply top and bottom by 3. 1 times 3 is 3. We have the 1, we have a common denominator 6. Now I can add the two numbers on top, which is 4, and I can reduce this to 2/3. Okay, so basically here we're not dealing with radicals at all, because the problem is asking us to write in with positive exponents. So all you have to do is take the exponents and add them, but be careful to make sure that the denominators they have a common denominator. Okay. Alright, let's go to problem letter D. Letter D, again, we have exponents. There are fractions, but in this case we're dividing, and the rule of exponents is if you're dividing something that has the same base, which is this case right here, what are you going to do with the exponents? Well, you're going to subtract. So 3/4 minus 1/8. The problem is we don't have a common denominator. So in order to have a common denominator and make this 4 here into an 8, I would have to multiply top and bottom by 2, and that's what I do over here. Once I multiply, 3 times 2 is 6, and I bring down the -1, and now I have a common denominator of 8, and 6 minus 1 is 5/8. Okay? Alright, very well. Then we have letter E. Letter E is, we even put a star by it because that's something that you might want to look into in preparation for the final exam. Okay, but basically here, letter E, we have a combination of multiplication and also division. So what I would do is just write the base A, and I'll write 7/4 plus 1/2 minus the 2/3. These are 2 are multiplying, so you add. These 2 are dividing, so you subtract. So now, what is the common denominator between 4, 2, and 6? And the answer is 12. So in order to make the 4 here into a 12, I will multiply both by 3, top and bottom by 3. Bring down the 1/2 to make this into a 12. I will multiply top and bottom by 6. Copy the next one to make this into a 12. I will multiply top and bottom by 4. In order to get a common denominator, 12. 7 times 1 is 21. 1 times 6 is 6. -2 times 4 is -8. We combine these numbers and we get 19, and that's it. You can just leave it like that. Okay? Alright, next one. I'm going to multiply the exponents to get rid of the parentheses, so we're going to distribute the exponents. So 5 times 1 is 5. Okay, 5 times 2 and 2/5. I wrote down over here on the side 2/5 times 5. The 5 cancels, you're left with a 2. Then we have -1/3 times 5, and there's nothing that can cancel, so 5 times -1 is -5. 3 times 1 is 3. And on the bottom, there's nothing we can do, just copy. Once I look at this, I notice that I can cancel the x squared, so I went ahead and canceled those. I also noticed that I have a negative exponent, so I moved that down. Okay, and this is a 1 right here. Okay, basically, what am I going to do with these two exponents? I'm going to add them. So what's the common denominator? It would be a 3, and that's what this means here. This was a 1, and I said, well, 1 has a denominator of 1, and we wanted to make sure that they have the same denominator. So what would be the common denominator between 1 and 3? And the answer is 3. So in order to make this guy here into a 3, we'll multiply top and bottom by 3. Okay, So once we do that, we have 3 over 3 plus 5/3. We can add them, and this would be y 8 over 3. And by the way, 2 to the 5th is 32, so then my final answer is 32 over y raised to the 8th third. Okay? Alright, very good. So those are our operations with exponents. There are fractions. So just remember, when you multiply, you're going to add the exponents, and when you divide, you're going to subtract them. Okay? Alright, let's move on to example number 5, which says write the following radical as a single radical. Okay? So we're starting out with an expression that has radicals, and we want to make it so that they are just one radical. Well, if you look over here, and remembering the past lessons, we cannot multiply these two radicals as are they written, because this is square root and this is cube root. So what should I do? Well, first thing we're going to do is change them into exponential form. So remember, there's an exponent 1 and there's an invisible 2, so it would be 1 over 2. We're going to change this into exponent form, so it would be 2 over 3. Now that are in exponential form, we're going to apply the properties that we used on the previous example. What can I do with the exponents? As long as you have the same base, you can add the exponents. So that's exactly what I do here. And I notice that 2 and 3, the common denominator would be a 6. So to make this into a 6, I would have to multiply top and bottom by 3. To make this into a 6, I would have to multiply top and bottom by 2. So that 1 times 3 is 3, 2 times 2 is 4, the common denominator is 6, 3 plus 4 is 7, 6. Once I have this, I can rewrite back into radical form. So remember, the denominator goes as the root, and the number on top is the exponent. Now I notice here, can I rewrite this so I can remove at least one y? And the answer is yes. I can rewrite as y to the 6th times y to the 1st. Y to the 6th comes out, so this would be y to the 1st, and this would be the 6th root of y. Okay? So that's that. Alright, now what we're going to do is letter B. Okay, letter B, we have the cube root of x divided by the 4th root of x. So basically what I'm going to do is change into exponential form. Remember, the root is the denominator and the exponent here is a 1, so the 1 goes on top. So it's x to the 1/3 divided by x to the 1/4. What I do with the exponents when I divide? I will subtract them. Find the common denominator, which is a 12, so 3 becomes a 12. I have to multiply top and bottom by 4. And 1/4, to change into a 12, I have to multiply top and bottom by 3. So 4 times 1 is 4, 1 times 3 is 3, common denominator is 12, 4 minus 3 is 1 over 12. This would be the 12th root of x. Basically, once I do the operation, the adding, subtracting of the exponents, I'm going to get one exponent. Then I can change it back into radical notation, because that's exactly what the problem is asking, to write the radical as a single radical. If you notice, these are single radicals. We started out with something that had two radicals. Now we only have one. Okay, let's continuing on. Suppose I have square root of 5 and the cube root of 2. Change. The first thing I would do is change into exponential form. That's what we did here and here. Notice that I cannot combine these two exponents because they have different bases, but nonetheless, what I'm going to do is I am still going to find the common denominator. Common denominator between 2 and 3 is 6, so I'll multiply top and bottom by 6. Here I'll multiply top and bottom by 6. And I cannot combine these exponents, so I'm going to change it back into radical form. And once I change it back to radical form, I have these. Now remember the rules of multiplying radicals. I can only multiply if they have the same radical. Do they have the same radical? Yes, they do. So basically, I can write just one radical, the 6th root, and I can put 5 to the third inside and 2 to the second inside. And here I kind of skipped a step. I did 5 to the third is 8. I'm sorry, 5 to the third is 125, 2 to the second is 4, and I went ahead and multiplied in my head. 4 times 125 is 500. But basically, what's happening here is, because they have the same root, that means they can be combined under this one single root, and I went ahead and multiplied these two. Okay, so let's go on to the next one and see what we get here. Here again, I change from radical into exponential form. I cannot add these two exponents, but I must find the common denominator. So I went and found the common denominator to be 6. So multiply top and bottom by 2 here, top and bottom by 3. Got the same denominator. Once I got the same denominator, I'm changing it back to radical notation. Because they have the same root now. Remember, before they didn't have the same root. Can I multiply these two? No, I can't. Now they have the same root. Can I multiply these guys? Yes, I can. 3 to the second is 9. 2 to the third is 8. 9 times 8 is 72. So the whole thing here, we're like kind of working around with exponents in order to be able to multiply the numbers inside the radical. Okay? Alright. This concludes the lesson B13. Okay, thank you very much for your time and have a great day.